Good morning, mathematicians. We are looking at lesson 6. This is thinking about expressions for volume and choosing an expression that matches the situation that you see in the prisms, of course, as you examine the side lengths and the length, the width, and the height. Now, in number 1, we are to look and determine which of the expressions do not represent the volume of the rectangular prism in cubic units. And yes, we will explain or show our reasoning. Let's actually start all the way down here with our 4 times 40. So as we take a look at this prism, can we see 4 layers of 40 cubes somewhere? That's what I'm examining this to determine and see if I can find that. Well, if I take a look here, I see that I have a length of 5 and a height of 8. So what does that tell me? That tells me that a vertical layer would have 40 units. And how many of those vertical layers would I have? What is the width of this shape? It's 4. So indeed, this situation does match, because as I look at this, I can see that I would have, let me just jot this down for us quickly here. We would have 40 units in a vertical layer times 4 layers. So again, that tells me that this does match. So I'm not going to be choosing that one because I'm going to choose the one that does not represent it. Okay? All right, well, let's go ahead to this one. Here in our next one, do we see 4 times 5 somewhere representing how many cubes would be in a layer, and then 8 of those layers? Well, indeed I do, because 4 times 5 would give me the area of the base. And then I could take that area of the base times the height, and of course my height is 8. So I'm seeing the area of the base, 4 times 5, times the 8 layers. So again, this one does match the situation, so I'm not going to be choosing that one. All right, let's come over here to our 20 times 8. Are we seeing 20 somewhere? And then the 20 cubes in a layer times 8 layers. Well, indeed, that is what we are going to have when we actually multiply the 4 times 5. We would have 20 cubes in the bottom layer, right? When I take the area of the base, 4 times 5, multiply it together and get 20, that's the number of cubes in that bottom layer. And then yes, there's going to be 8 of those layers. So once again, I know this is not the one I'm going to choose because it is an example how we could represent it, right? We're really looking for the non-example. Now over here, as I look at this, I am seeing that is the one that we're going to choose, because once we find the area of the base, the 4 times 5, we only need to multiply it by the height of 8. We don't have to multiply it by this other 4 over here. We have already done that, right? So I am going to move kind of our brainstorm answers up top now that we've talked through those, because these are not our answers. That was really like our brainstorm, okay? Now I am going to go ahead and do an answer box down here, because now I'm going to talk about the one that does not work. And the one that does not work is the first one. So we are going to write that 4 times 5 times 8 times 4 is not a representation of the volume, because once you find the area of the base with 4 times 5, you only need to multiply by 8. Okay, now, and I could even say specifically by the height, which is 8, because then I am also specifying exactly what that 8 means. All right, so all of this thinking that we did as we were thinking about these expressions and which one was and which one was not going to be an answer that we would choose, we've really done all the thinking for the first question, but really also for the second question as well. So that's why I don't want to erase this. This thinking, the brainstorm that we did, is actually going to be important to our next question. But let's be clear, what we have right here, what I just highlighted, that is the actual answer for number 1. The other ideas that are now kind of chicken scratch around the expressions were just our thinking for the ones that do work and how we saw that in the particular prism. But this is our answer for number 1, what I have just put in bold letters. Now, when we go down to number 2, number 2 says that we're going to choose one of the expressions from above, and we're going to explain why it represents the volume of the prism in cubic units. Now, you'll notice my color coding, all right? Now, what we had up here, the 20 times 8 in blue, I have just given a little bit more information down below so that if you chose that one, you can check your work with what we have in blue, because you did not have to do all 3. I did all 3 so that you can take a look at those, but you are just going to take a look at the blue coupled with the blue one down below. So if you chose 20 times 8, 20 times 8 represents 20 square units as the area of the base times a height of 8 units. 20 times 8 equals 160 cubic units. So that would be how that represents it, an explanation of how it represents it if you chose the 20 times 8. Now, if you chose what here, I have my notes in green around, you chose the 4 times 5 in parentheses times 8. And that represents the area of the base found with 4 times 8 times a height of 8 units. So 4 times 5 times 8 equals 160 cubic units. That would be an explanation of this third expression. The final expression is 4 times 40, and 4 times 40 represents 4 vertical layers with 40 cubes in each vertical layer. So 4 times 40 equals 160 cubic units. So in essence, boys and girls, this very first expression, we have explained why it is not an example in the words that have the box around them, the rectangle around them. Now, in this second expression, 20 times 8, we have explained in red. This third expression we have explained in green, and the very final expression here we have explained in red, except it's the very bottom red down below. Boys and girls, as we did this lesson 6 today, we were really challenging ourselves to represent our prisms with expressions, as well as thinking flexibly about not only the expression that I saw, but maybe an expression that a peer saw, or even just that was presented to us in our illustrative math ideas. That finishes our lesson 6 cool down.